In today's video, we are going to explore how to separate both soluble and insoluble solids from liquids using three fundamental techniques in chemistry: filtration, evaporation, and crystallization. But before we get into the practical methods, it is essential to understand some basic terminology. When a solid is added to a liquid and it does not dissolve, like when sand is mixed with water, what we have is simply a mixture of a liquid and an insoluble solid. On the other hand, if we mix a solid that does dissolve in the liquid, such as sodium chloride salt in water, the result is called a solution, where the sodium chloride is known as the solute and the water is referred to as the solvent. Now, the first technique we will cover is filtration, which is used to separate insoluble solids from liquids. It works very much like using a sieve in the kitchen when cooking to separate solids from liquids, but in a laboratory, we use filter paper instead, which contains numerous tiny pores that are small enough to allow the liquid to pass through while blocking the solid particles. This filter paper is usually placed inside a funnel, known as a filter funnel, allowing us to pour the entire mixture through it so that the liquid drips through while the solid residue stays on the paper. However, this method does not work if the solid is soluble and has already dissolved in the liquid, forming a solution. In such cases, filtration is ineffective, and we must turn to either evaporation or crystallization. Evaporation involves placing the solution into an evaporating dish or a crucible, which is generally supported on a tripod and heated slowly using a Bunsen burner. As the heat causes the solvent to evaporate gradually, the remaining solution becomes increasingly concentrated. Eventually, crystals start forming due to the high concentration, and if we continue heating, all of the solvent will eventually evaporate, leaving behind dry, solid crystals. Evaporation is a relatively fast and straightforward method to separate a soluble solid from its solution, but it has a major drawback. Some substances cannot tolerate high temperatures and will chemically break down when heated, a process known as thermal decomposition. For these heat-sensitive substances, we need to use a gentler method called crystallization. This process also begins by placing the solution in an evaporating dish, but instead of applying direct heat, we heat it gently, often by using a warm water bath instead of a direct flame. Once a portion of the solvent has evaporated and crystals start appearing in the remaining liquid, we stop heating and let the solution cool naturally. As the temperature drops, more crystals form because solubility of solids typically decreases in cooler liquids. After cooling, we filter out the crystals using filter paper and a funnel just as we did during the filtration process. Finally, to dry the collected crystals, we either leave them in a warm environment or place them in an oven at a controlled temperature. And with that, we conclude our discussion on the separation of mixtures using filtration, evaporation, and crystallization. If you found this helpful, please do give the video a like, consider subscribing to the channel, and we will see you next time.